On our next one, we're going to talk about how do we graph a function. So in our vocabulary piece, we talked about what the word domain meant. Domain means x. So we simply need to plug all of these numbers in for x, and then we can decide if it is a function by graphing it. So we have x, we have y. We're going to put 0, 1, 2, and 3 in for x. So I can say 3 times 0 minus 4, negative 4, 3 times 1. Minus 4 is a negative 1. 3 times 2 minus 4 is 2. And 3 times 3 minus 4 is 5. Now, I can see right here, it is in fact a function. All linear equations are going to be functions. So when I graph these, I'm at 1, 2, 3, 4. 1, negative 1, 2, 2, and 3, 5. And I can see this is in fact a function. Also, it will pass the vertical line test, no repeat x's. This is a discrete representation. We talked about this when we talked about the push-up and the pull-up. So this is individual data points, okay? It doesn't tell us to connect the dots. These are individual data points. So there is our domain. So if we needed to, we could write the range that goes with it, which would be these y values, negative 4, negative 1, 2, and 5. We can also use a fraction in this. So we have x equals, so again, x and y. And we can say 0, 2, 4, and 6. So again, we're just plugging in. Half of 0 is 0, plus 1 is 1. Half of 2 is 1, plus 1 is 2. Half of 4 is 2, plus 1 is 3. Half of 6 is 3, plus 1 is 4. So again, this is a function. Excuse me. And we can graph it. You can also simply graph by y equals mx plus b. So I'm at 1, and I'm going to go up 1 over 2. There's my 2, 2. Up 1 over 2. There's my 4, 3. Up 1 over 2. There's my 6, 4. So again, it is a function. How do you write a rule for a function? All right, well, when we're writing those rules, we're just writing them in y equals mx plus b format. So remember, m is our slope, our change in y, over our change in x, and b is our y value when x is 0. So sometimes that 0 is not on the chart. So we can see this is plus 1, this is plus 1. So my slope is 1 over 1, which is 1. And my b value, I don't have a 0 here. But I can work backwards. I can say, okay, 1 plus 1 is 2. What plus 1 is negative 1, negative 2. And I still need to get to 0. So what plus 1 is negative 2, negative 3. My b value is negative 3. So we have y equals, we can write 1x if we want, or just x minus 3. This one is non-proportional. It doesn't go through the origin, if you remember that from 7th grade. This one's proportional. We've got plus 3. We have plus 9. Change in y over change in x is 9 over 3. So our slope is 3, so y equals 3x is our function. Here's my b value on this one. It's given to us. Plus 1, plus 3. 3 over 1 for our slope, or 3. So our equation is y equals 3x plus 2. We can also do this with a graph, okay? And when we do this, we're still doing y equals mx plus or minus b. So I have 1, 2, 3, 4, 5, 6. My b value is 6, and my slope is rise 1, run 1. So y equals, you can put the 1 if you want, x plus 6. Here, we don't have a b value, but we can count backwards. So we have my slope is rise 2, run 1. And we can do this a couple of ways. We can work backwards. I'm going to show you another way. We know it's going to be y equals 2x plus or minus b. Well, we have a coordinate here, 1, 2, 3, 4. So this point is 4, 0. We have an x and a y. Well, we can plug those in down here. 0 equals 2 times 4 plus or minus b. And we can simply solve the equation. We're going to add 8. B is 8. Excuse me, negative 8. This is a positive. I apologize. Positive 8 becomes negative 8 when we move it. So if our b is negative 8, then our equation is y equals 2x minus 8. And we'll work some more on writing those types of equations. Okay? Keep in mind, if you have repeat x's, it is not a function. If it doesn't pass the vertical line test, it is not a function. I'm sorry, if it doesn't have repeat x's, it is a function.